Hi! Today we will learn how to use implicit or partial differentiation to find the maximum or minimum value of a multivariable functions. Finding the maximum and minimum of a function is one of the interesting topics in calculus. So without further ado, let's proceed. So let's say we have to evaluate the maximum and minimum of a unit circle. X squared plus y squared equals 1. I think x squared plus y squared equals 1 is the most basic multivariable in calculus. Somehow, we already know that the maximum values of x and y of a unit circle is plus minus 1 for x and plus minus 1 for y. So how do we solve these values using calculus? That is by differentiation. Till the end of this video, I will use the partial differentiation. So anyway, if you use the implicit one, it's still the same results. So first, we take the derivative of x squared plus y squared equals 1 in terms of x. In partial derivative, we take the other variable as constant. So if you have x squared in terms of x become 2x. Since y squared is considered as constant, becomes 0. So the derivative in terms of x is just 2x dx. Now we take derivative in terms of y. So become the y squared equals 2y. And the x squared is same as the we consider as a constant. So by partial derivative, x squared plus y squared equals 1 is just 2x dx plus 2y dy equals 0. Now we transfer 2x dx on the right hand side, become negative 2x dx. By rearranging our equation, we can have dx over dy equals negative y over x and dy over dx equals negative x over y. To find the maximum value of x, we need to set dx over dy equals 0. For y, we need to set dy over dx equals 0. Some tips: if dx in the numerator part, then that is for the x maximum or minimum value. If dy is in the numerator part, then it's for the y maximum or minimum value. So here is the graph of our unit circle. Dx over dy equals 0 refers to the line that is parallel to the y-axis. So by that, we will find the x maximum or minimum value. For dy over dx equals 0, that is refer to the lines that is parallel to the x-axis. That's why, by that, we will find the maximum value of y. So let us find first the maximum and minimum value of y. So we need to set negative x over y equals 0. Since it's fraction, in order to be 0, then its numerator x must be 0. So we need x equals 0. When x equals 0, we have maximum or minimum values of y. And that makes sense because when you input x equals 0 in our original equation, that is x squared plus y squared equals 1. When x equals 0, we have only y squared equals 1. And that is y equals plus minus 1. And that is the desired value we're looking for. Now for x part, to find its maximum or minimum value, we need y over x equals 0. And that is y equals 0. So when y equals 0, we have maximum or minimum value of x. So again, substituting on the original equation, we only have x squared equals 1 and x equals plus minus 1. And again, that's the value we're looking for. By using partial differentiation, we just find the maximum and minimum values of x and y's. Again, here is the graph of our unit circle. We have maximum y equals 1 and minimum y equals negative 1. And for x, x equals 1 and x equals negative 1. Since we are done with the basics, so let's proceed to a bit more complicated functions. Now we need to find the maximum values of x and y of the function x squared plus y to the fourth minus xy equals 0. So here is the graph of our function look like. Now we do partial derivative. Just like we do in our unit circle, in terms of x, we consider y as constant. So derivative of x squared is 2x. Derivative of y to the 4 is constant. So derivative of constant is 0. Minus derivative of xy is y. For y part, we consider x as constant. So derivative of x squared is 0. And derivative of y to the 4 is 4y cubed. And derivative of xy is negative x. So all equals 0. Transferring the dx part on the right hand side become negative. By rearranging our equation, we can have dy over dx equals negative 2x minus y over 4y cubed minus x, and dx over dy equals negative 4y cubed minus x over 2x minus y. So anyway, if you find 1 dy over dx, you can just flip so that it become dx over dy. So here's the graph of our function. We need to set them both equal to 0 to find the maximum and minimum. Dy over dx equals 0 denotes the line parallel to the x-axis, while the dx over dy is the line parallel to the y-axis. If dy is in the numerator part, then we're looking for y maximum or minimum value, while for x, the dx is in the numerator part. Okay, for y part, we need 2x minus y equals 0. That is the numerator equals 0. So we have x equals y over 2. By substituting y to the original equation, that is x squared plus y to the 4 minus xy equals 0. So we have y over 2 squared plus y to the 4 minus y over 2 times y equals 0. Simplifying, y squared over 4 plus y to the 4 minus y squared over 2 equals 0. Since y squared over 4 minus y squared over 2 same as negative y squared over 4, become y to the 4 minus y squared over 4 equals 0. Now we factor out y squared, become y squared times y squared minus 1/4 equals 0. So the solution of this factorization is y equals 0 and y squared equals 1/4 and y equals plus minus 1/2. So we have maximum of y equals 1/2 and minimum of y equals negative 1/2. You might be wondering what happened to y equals 0. Well, that's not the value we're looking for. The absolute maximum of our function of y equals 1/2 and minimum of negative 1/2. We're done with the y part, so let's proceed with the x part maximum or minimum value. Since dx over dy equals negative 4y cubed minus x over 2x minus y equals 0, we need only the numerator equals 0. So 4y cubed minus x equals 0. We divide 4 and we take the cube root, same as y equals the cube root of x over 4. And this form is same as x over 4 raised to the power of 1 over 3. Now we have the y value. We need to substitute to the original equation, x squared plus y to the 4 minus x over y equals 0. Now we have x squared plus x over 4 raised to the power of 1 over 3 raised to the power of 4 minus x over 4 raised to the power of 1 over 3 equals 0. Simplifying, x squared plus x 4 over 3 over 4 raised to the power of 4 over 3 minus x times x raised to the power of 1 over 3 over 4 raised to the power of 1 over 3 equals 0. Now we have x squared plus x 4 over 3 over 4 over 3 minus x 4 over 3 over 4 1 over 3 equals 0. We can factor out x 4 over 3 become x 4 over 3 times x to the 2/3 plus 1 over 4 over 3 minus 1 over 4 over 1/3 equals 0. 4 over 3 plus 2 over 3 is same as 6 over 3 equals 2. And we just factor out x 4 over 3, so remaining numerator is just 1s. 4 over 3 is same as 1 plus 1 over 3. So same as 1 over 4 times 4 to 1 over 3. For these terms, we can combine them by multiplying this one by 4. So denominator times 4 and numerator times 4. So now we have 1 minus 3. So our equation become x to the 4 over 3 times x to 2/3 minus 3 over 4 to 4/3 equals 0. So we have a solution, x equals 0 and x to the 2/3 equals 3 over 4 to 4 over 3 by transferring 3 over 4 to the 4 over 3 to the right hand side. Now multiply both exponent by 3 over 2. So same as plus minus because it involved the square root. So x equals plus minus 3 over 4 to the 4 over 3 and all to 3 over 2. So become 3 raised to the power of 3 over 2 over 4 raised to the power of 4 over 3 times 3 over 2. It's a property that we just multiply the exponent. So become 3 to the 3 over 2. The denominator part 3 cancel and 4 and 2 become 2. So we have 4 square remaining. So simplifying, x equals plus minus 3 square root of 3 over 16. So approximately plus minus 0.3248. So finally, we find the maximum and minimum value of x. That is maximum of 0.3248 and minimum of negative 0.248. So here is the graph of our function. The highlighted points is where is our maximum and minimum value. For y, we have 0.5 and negative 0.5. For x, we have 0.325 and negative 0.325. That's all. Thanks for staying till the end.